Welcome to another GCBASIC demonstration. This is part 4 of the videos for the PIC18xxQ20. Preamble. Like the video, let the video run to its end because YouTube measure that. If you don't see it to the end, it doesn't count, and subscribe to the channel. So what are we doing here? We're looking at a set of videos for the Q20. What we've done initially is set the LEDs going. We've flashed the LEDs, we've put them in a sequence, and we've set the LEDs in the previous video to represent the value of the ADC. Today, what we're going to do is use a delay from the ADC to change the speed of the sequencing. The hardware, what we're going to be using is a prototype board. It's powered at 5 volts, has a programmer attached, LEDs and resistors are attached, and a potentiometer. And the diagram shows that the ADC is on port A.0, and the ADC is on port 0, and the LEDs are on port C. 7, 6, 5, and 4 are the LEDs. Let's have a look at that on desk cam. Here's desk cam. That's where I left it yesterday. If I rotate the pot, the LEDs will change. Look, there we go. That's where we left it yesterday. Brilliant. Chips over here. I've got 4 LEDs connected into the C port over here, and I had this potentiometer connected through this flying lead. It comes out essentially a port A.0 here. Very simple setup, but it's quite representative of what we want to do. So what we're going to do is we're going to use the ADC to control this speed of rotation or this sequencing, and where speed could be microseconds or units of time as shown on the screen, 10 microseconds, milliseconds, etc. And we're going to use like wait time unit. So wait 1 millisecond is a fixed constant of time, but we're going to change the 1 into a variable. So what we're going to do is have GCBASIC do the initialization. We're going to create a variable to store the ADC results. And then we're going to read the value back in. And that value is going to be a return value of 0 to 123. And then we're going to wait for a time based upon that result. Set the LEDs and do it all again. From a flowchart point of view, relatively simple. Initialization, set 1 LED. We did that in the previous videos. Read the ADC, wait for a delay, rotate the LEDs. Did it overflow? If it did not overflow, just keep doing the same thing. If it does overflow, go back to the first state. And we're going to get a value back of between 0 and 1023. So we now know that we're going to get a value of 0 milliseconds to just over 1023 milliseconds. And you can work out that's just over a second. Let's have a look what we've got, and we'll go and have a look at some codes. I'm in the IDE here, and I'm just going to press Control B, and I'm going to open up 060. So 060 variable rotation, and just Control B and get rid of that. And so you can read the commentary on your own, but essentially I'm going to go straight into it, into the effective pieces. So I've got a chip 16Q20, and then I set up the constants previously, and they're constants to the ports. So if you wanted to change them, you could. LED 7 is on port 7, etc. It's better to use constants because if you change one, it changes the whole program. The meat of the program is down here. We've created a variable previously, but now we're going to create a word variable to hold our returned value. It's bigger than a byte. It's a word. It's somewhere between 065355, and because our range is 0 to 1023. And so we create AD value as a word, and that gives us the range that we're looking for. We set the LED to 1, and then we have our do loop. You can see the do loop on the screen here. If I indent that a little bit more, look, maybe that will make it easier for you to see. There's a do loop, do it forever. And essentially it says read the AD port, AD10, because we want a 10-bit value, and we're going to put it inside of the value called ADC. Please ignore the red stuff for the time being. I'll come back to those shortly. Wait, ADC val, milliseconds. rotate the port left. If it overflows, set LED 4. Do it again. So the only time it will go back to LED 4 is if it overflows. Compile it. Press function key F5. You can do it through other ways, the icon at the top right hand corner, or press function key F4 and select flash and from the menu. Let's go back to desk cam. Desk cam is rotating as expected because it's very simple what we're doing. If I now use my screwdriver, it will actually delay that to 1.023 seconds. And if I change the frequency of the chip, it will work. You just have to trust me, it just will. If I bring it back, it gets faster and faster and faster, faster and faster and faster as it becomes nearly zero. Now, GCBASIC is highly optimized. So if I have a weight of 0, that is no time at all, it will just ignore that. And because it ignores it, you get a very strange reaction when you go back to 0. Weight of 0 is no delay at all, and it sort of flops out on you. So what we're going to do is we're also going to change the range that it returns. And I'll show you how to do that in the code. Go back to the code. We're going to use something called scale. And scale is in red here. We could use scale, or we could use this if statement, your choice. But let's use the if, and we'll look at both. So I'm going to delete the commentary away and say the following. If the ADC value is greater than 0, then do the weight. So I'll just comment this one out. If you press Control /, it adds the comment in. So I've very quickly changed the program. If ADC value is greater than 0, therefore 1 to 1023, then it will resolve the problem of a weight of 0. Let's program that out, and we'll wait for that on desk cam to do its stuff. So if I come into the potentiometer, it's programmed it. If I now rotate that down, it goes very fast because it's now the minimum of weight 1 millisecond. You can see it's very fast, but very effective. I mentioned this other piece of code that I prepared, and I'm just going to go back to it. I'm just going to comment out the weight and put the weight as it was, and I'm going to change it a different way this time by changing the scale. Scale is a very useful function. It's going to take the value that's returned from our ADC, and we know the range of that is 0 to 1023, and I'm going to say to it, I want you to move that, change that to a range of 1 to 500. So that's 1 millisecond to 500 milliseconds. I could put 2,500. I could put anything in there as the maximum number, up to 32,678. And it's a very good way of scaling, changing the range of a return value. So if I press that and I'm going to program that, we'll go out to desk cam. It is quite fast, so it's in terms of its end-to-end operation, it's quite fast. So here we have the potentiometer, and if I put that full on, that's half a second per LED. If I now come all the way around, we're at 1 millisecond. And I could get the scope out, and we could prove that. But essentially what we're looking at here is two sets of controls. We're looking at controlling the LED flashing by the ratio of the ADC, the value, and then we've changed the scale of that to give us better flexibility because a weight of 0 is just optimized out. And so that's all I wanted to cover. It's a very simple demonstration today. Let's go back to the PowerPoint. So scale transforms an existing value to a new value within a specific scale. And we saw that work. We saw it scale from 0 to 123 to 1 to 500. I think the Arduino also has the same function, does the same thing, and you can do offsetting, so it's a very useful function. So, sequence the LEDs with a delay. We've done that. So far we've installed the hardware, made the LED work. We've done some sequencing, we've done some ADC, we've done some delays. So Next video will be we're using the input state to change the state of the LED. So so far we've been doing outputs. Now we're going to move to an input state. So we're going to change the focus with some switch because that PCB, that board we have, has some switches on as well. And typically you need inputs and outputs in a solution. So that was part 4 GC Basic. Please like the video and enjoy.